Alright, today is Tuesday, November 4th, 2014. Welcome to week 2.4 of Togetherness. Ready to learn?
Ready to learn.
Alright, you need your pencil, the Module 8 book from yesterday, your notebook, and a planner. I'm going to ask you to go ahead and open your notebook to the Notes and Practice section. And then open the Module 8 book to page 4. We're going to start with page 2. We're going to start with number 4 from lesson 3. Alright, today's outcomes are I can solve linear equations and I can make sense of problems and persevere in solving them. Today's question is the same as last week. When it comes to negatives, what do we notice when we use the distributive property and when we are multiplying and dividing negatives with inequalities? Homework tonight. If you did not complete the assessment online, you need to get that done by tomorrow. Okay? So tomorrow when you come into class, that needs to be done because I'm going to grade them. And once I start grading, I'm only going to go through one time and grade. And then I'm going to delete the link. So make sure you get it done. And then also practice. Practice integers and also practice with the blackout. Those are 2 grades that you already have in Power School. So if you want the opportunity to redo them, then you need to be practicing so that you can redo them. Any questions so far? The blackout, you're going to redo the blackout in class. That's why I had Rayon write that note on the board. So right now I just need you to be looking over the blackout. Alright, today's agenda, we're going to be talking about solving equations for most of the time, and then there'll be one assignment that I'm going to ask you to turn in just so I can see where you are and how you feel about solving equations. So, at the top of your notebook, I want you to write solving equations. That's going to be the title of the lesson today. And today is November 4th. And we're going to start by looking at page 2 from lesson 3, specifically problem number 4. Okay, these problems relate to solving equations from last week. We had the balance beam, and we had 2 sides of it. And if we took something from the left, we also had to take it from the right. We had big blocks, and then we also had little blocks. And sometimes on this side, we had a number like 10. We're going to apply that same principle, but this time we're going to be solving problems algebraically. Inverse operations. Write these down. To solve equations, you perform the inverse operation. The inverse operation of adding is what?
Subtraction.
Yep, subtraction. And the same thing, it works both ways. The opposite of subtraction is adding. So I'm going to make this an arrow on each side. The opposite of multiplying is dividing, and the opposite of dividing is yes. And then the last inverse operation, it's a little tricky. It is multiplying fractions. When it comes to multiplying fractions, the inverse is dividing fractions. And if you think back to 6th grade, dividing fractions was a little bit more complicated. To divide a fraction, anybody remember how to divide a fraction? Allison, how do you divide a fraction? Alright, a T. Right, y'all both said the same thing. You have to multiply by its reciprocal. So whichever fraction you are dividing by, you flip it and multiply. That's reciprocal. RECIPROCAL. Multiply by its reciprocal. And we're going to work on that a little bit today also. Okay, let's look at page 2, number 4. Alright, the problem is x plus 6 equals 8 plus 7x. And they are asking us if x equals negative 1/3 is a solution. In order to determine if it is a solution, we are going to substitute negative 1/3 in for the variable x. So, change this color. Negative 1/3 plus 6 equals 8 plus 7 times negative 1/3. And I'm going to draw my little river. Anytime you cross the river, it becomes the opposite. So if you go across the equal sign, you have to make it the opposite of what it is. Because if you are adding, let's say you got plus 6 on both sides. In order to get rid of plus 6, you have to subtract. But you have to subtract it from both sides to keep it balanced. So keep that in mind. If we cross that river, we have to perform the opposite operation, the inverse operation. Alright, so first let's look at negative 1/3 plus 6. That's 6 minus 1/3. What is it? Keith. Alright, Keith says it's 5 2/3. Do you all agree? Alright, so negative 1/3 plus 6 is 5 2/3. And I bring down my equal sign. Now, on this side, we have to use order of operations, which says we need to multiply here first. We have negative 1/3 7 times. That's like negative 1/3, negative 1/3, negative 1/3, and you just keep adding them 7 times. If you add negative 1/3 7 times, 3, 4, 5, 6, 7, this is a 3/3. That's 3/3, and that's a third by itself. So negative 1/3 times 7 is negative 2 1/3. And then you also have to bring down the 8 that you are adding to that negative, or that negative 2 1/3 is being added to. I don't know. I don't know what 8 plus negative 2 1/3 is. Negative 5 or positive 5? It will have to be a positive. Alright, so let's see. If I got this third, I need 2 more thirds to go with it, right? That'll give me a whole. So that'll be 3. The difference between 3 and 8 is 5. So you need 5 to get up to the 8. And those are equal to each other. So yes, it is a solution. Whoop, whoop. Did you all have a chance to go over the problems from yesterday together? Or at least work on them together in class?
Yes, ma'am.
Alright, we're going to go to lesson 4. So once you finish writing that problem, flip over to lesson 4.
This is on page 4, right?
Yep. Lesson 4 is on page 4, and the title of it is still Solving Equations. Alright, I'm going to ask that you be comfortable with being uncomfortable in solving these problems, okay? We're going to go through all 5 of the problems together. Once we grapple with those 5, I'm going to bring you back down to an easier problem that'll hopefully be easier than problem number 5 that we get to. So here's what we're going to do. I'm going to take you all the way up to the top of this very high mountain. And then I'm going to take you back down to the bottom of the mountain and expect you to be able to walk 3 steps by yourself. Okay? So it's going to be a little workout, and then you're going to do a little bit by yourself. I'm going to train you by doing 100 push-ups. Then I'm going to expect you to be able to do 10 of them without me. Jumping jacks. Pretend like you can. Alright, let's go. So, we are writing this in our notebook. Lesson 4. First problem we're going to look at is x plus x plus 2 plus x plus 4 plus 6 plus x equals negative 28. And I think I said that wrong, but I wrote it right. And look, for 6 period, you all can pause this video as needed and come back and play. You can also overlook our comments if we get a little off task. Just wanted to put that out there for them. Okay, so if you think back, this is like a balance beam. Here is the center of the balance beam. On the left hand side, we have all these terms, and it equals negative 28. Here's my little song. First, distribute and combine like terms. Okay? First, distribute and combine like terms. You want variables on one side, numbers on the other. When you move it to the other side of that squiggly line, it becomes the opposite. First, distribute and combine like terms. You want variables on one side, numbers on the other. When you move it to the other side, it becomes the opposite. Okay? When you move it to the other side, it becomes the opposite. So, like terms on the left-hand side, plus equals
4x.
4x. No, not x4. This is not the matrix. No, the problem, it says negative 28 on that side. The problem from the book says negative 28, and that's what you write. Okay. Yes, sir. Oh, wait, no. Answer what? No, you're not finished, because you got a plus 2, a plus 4, and a plus 6.
12.
Plus or minus? Yeah, you're going to put them all together. What is it?
Right?
Plus 12 is right.
Yeah.
Now, imagine you have these 4 boxes that you don't know what they contain, and then you got these 12 little cubes from last week, and that equals negative 28. The first thing we need to get rid of are these 12 little cubes. How do you get rid of the 12 little cubes? Alright, so we're going to subtract 12. If we do it to one side, you got to do it to the other. There you go. So 4x is still left on the left-hand side, and that equals negative 40, says the man in the front. Nick, right. So 4x's is negative 40. What's the value of each x? Negative 10. How'd you get negative 10? Okay, this is 4 times x. What's the inverse operation for multiplying? So I divide. What is a positive divided by, a negative divided by a positive?
Negative.
So x is negative 10. Voila. Take a minute and write that down if you haven't. Once you finish writing that, go ahead and set up for problem number 2.
That makes sense.
All right. How was that? Okay or awful? It was okay.
Pretty easy.
Okay. Only get it a little bit. That's fine. If you got it a lot, you wouldn't need me. Number 2. Let's write it. 2 parentheses 3x plus 2 close the parentheses equals. Thank you. Alright, so I said first distribute, then combine like terms. Then you want your variables on one side and numbers on the other. When you move it to the other side, it becomes the opposite. So let's go back to the first distributing. On the left-hand side of this equal sign, Bryce, I have 2 sets of 3x plus 2. So, if I have 2 sets of 3x's, how many x's do I have? Bryce. Yep, I got 2 sets of 3x's. How many x's do I have? 6x. If you agree, say mm-hmm. If I have 2 sets of 2's, Gideon, How many do I have? He says 4. If you agree, say sure enough.
Sure enough.
I said sure enough, not sure enough. Sure enough.
Sure enough.
Thank you. Yeah, that was funny. Okay. 2x minus 1 plus x. I need to clean this up. Clean up this mess.
Wouldn't it be 3x minus?
Yes, Nick. Thank you for raising your hand. It's okay. You were the only one talking. 3x minus 1. He was the only one talking at that moment. Okay. So look. On this side I have 6 x's, and on this side I have 3 x's, and I need to clean them up because I want to get them all on one side to find out what is the value of one of these x's. So how do I get rid of the 3 x's on this side? Yep, I'm just going to subtract. I'm going to take them off. And if I take them off on the left, I need to take them off on the right. Or if I take them off on the right, I got to take them off on the left. So that's going to be the first step. Let's subtract the 3 x's so that we can try to find out what this x is worth. If you do it to one side, you got to do it to the other. It's gone. Bam! Bring down negative 1. 6x minus 3x. Say it again, Hayden. 3x plus 4. Now, clean up that mess because I got some loose change over there. What's my loose change, Hayden? Well, yeah, what I need to move? From the left-hand side, what do I need to move? I need to get rid of the plus 4. Isabella, how do I get rid of the plus 4? You subtract it on the left and you subtract it on the right. That is correct. Subtract it on the left and subtract it on the right. This is gone. This comes down. And what is negative 1 minus 4?
Wouldn't it be?
Negative 5. So 3 of these x's is worth negative 5. Huh. That's impossible. So this is 3 times x. How do you get rid of 3 times x? What's the inverse of 3 times? Divide by 3. I am totally okay with fractions. Fractions are my friend. We've been together for a long time. Fractions and I, we ride or die. Here we go. Fractions are amazing. I agree. Alright, so x, the value of x is negative 5/3. Are there any questions on that problem? Uh-oh, just give me one question, Yasmin, because I don't want a lot. Why we divide by the same number? Because you're trying to keep it balanced. So if you pop her on the head on the left side, then you got to pop her on the head on the right side. No. Otherwise, it's going to be off balance and she'll be like that. So I got to pop her back. Okay? So what you do to one side of the balance beam, you have to do to the other side. Number 3. Yes. Because I got 3 for the denominator because I divided both sides by this 3 to get rid of it. So basically there are 3 boxes over here and they total, I'm going to give you an even number. Let's say they total negative 15. If these 3 boxes all together make negative 15, then you got to divide that negative 15 among those 3 boxes. And so each box will be negative 5. But in this case, it's not a nice even number. It's negative 5/3. What, ma'am?
Okay, so why did you simplify the fraction?
Okay, simplify the fraction. Or x equals negative 1 2/3. That was a good question. I did. That was not a reason I didn't do it other than I was being lazy. Are we ready? Problem number 3.
So that's on page
Problem number 3. Let's go. Oh yeah, I heard you. I thought it was her. Like, really? You should keep your hands to yourself, Nick. All right, here we go. Let's focus. Number 3. Write it down. Here's the problem for number 3. Write it down. Nine less than the number x is 3/5 of the number. That's why I said it like that.
English, please.
9 less than the number is 3/5 of the number.
Oh, I get it now. Why can't you just say x minus 9 equals 3/5 x?
X minus 9 equals 3/5 x.
That's English. That is so confusing.
All right, here we go. Well, here's that middle of the balance beam. And on the left-hand side of the beam, I have an x, and I'm taking 9 away. So I got x and like 9 negatives over here. And then on the right side, I have 3/5 of the x. I always say I need to get rid of the loose change and clean it up to simplify it. It just makes sense to me. I don't really have a reason for saying that. So I'm thinking about what we did last week, and on this side of the beam is x minus 9, and on this side of the beam is 3/5 x. What do I need to get rid of first? The 9. How am I going to get rid of 9 negatives?
You add 9.
Yeah. Add 9. What you do to one side, you have to do to the other side. Now, can I combine the x's and the 9s? Like, can I write them as one term, or do I have to write them as 2? I do have to write them as 2, because that's like trying to combine triangles with cubes. It just doesn't go together. Doesn't make sense.
They do.
It's kind of like trying to mix dirt and water. That's mud. All right, here we go. 3/5 x plus 9 equals. Only thing left on this side is x.
Because negative 9 plus positive 9 would be 0. So
It cancels out. I'm going to take my jacket off. Excuse me. Why am I adding 9? I am adding 9 because I need to get rid of the 9 negatives.
isn't
And in order to get rid of negativity, you got to add some positivity to it. Okay.
3/5 1 and 4?
You can't combine 9 and 3/5 because they're not alike terms. You can only combine the terms that are alike. All right, so here, Bryce, I need to get rid of the 3/5 x. In other words, I need to eliminate it. And right now, it's just sitting on this side of the balance beam. How do I get rid of it? How am I going to get rid of the 3/5 x? That's the question.
You gonna divide it?
I am going to subtract it. You can't divide it because we're not ready. You don't divide anything until it's simplified. Okay, until it's in its simplest state. And right now, this equation is not in its simplest state. So we're going to just pick up the 3/5 x from the left-hand side. And if we pick up 3/5 x from the left-hand side, we got to pick up 3/5 of an x from the right-hand side. So pick up 3/5 x from the left-hand side, too. Whoop. It's kind of crooked. Okay, these cancel. Look up here at the board. This is what you see this empty space? I am going to write 5 over 5. Because that's the same as 1. I wrote 5 over 5 because 3 over 5, it makes it easier to deal with that fraction. All right, Nick, tell me. 5/5 minus 3/5 is...
Thanks, Nick. 2/5.
2/5. Rayon, what goes on the right hand side? What am I bringing down? What's left over here?
9.
The 9 is left. Now I am ready to divide and conquer. 2/5 of a number is 9. This is multiplying by a fraction. Shannon, look back at your notes on the very first page. How do you get rid of multiplying by a fraction? Take the inverse and do what? Look back. At the very top, we were talking about the inverse operation. Divide by the fraction. How do you divide by the fraction? Multiply by the reciprocal. So let's go back. Let's divide by not 2/5, not 3/5. We're dividing by 2/5. Do it and don't look up unless you want to check your word. Take 9 and divide it by 2/5. I am not going to talk through the process. And you shouldn't talk either. Work.
Also 22.5. I mean 22 and a half.
45 divided by 2.
Oh.
Good. All right, are there any questions? Uh, 9 divided by 2/5, to divide by a fraction, you multiply by the reciprocal of that fraction. And you multiply straight across. 9 times 5 is 45, 1 times 2 is 2. 45 divided by 2, I start to do the math up here. And I got 22.5. Because that'll be a 4 and then a 1, 0. Yes, ma'am. You can leave it at 45 over 2. Yeah, improper. No, a proper fraction. Mixed number. That's it, mixed number. Okay, I made this 5 over 5 because it was a 1x. And it was easier for me to deal with 1x minus 3/5 x by making that 5 over 5x. How much time? We have 10 minutes. Let's go to number 4 and 5. And then we'll be done. All right, number 4, write it down. And start on it. I wonder how far you can get. There's the bridge. Are there any parentheses or light turns that I can get rid of? No, on the same side. In the same pan. Anything in the same pan that I can combine.
Yeah.
What?
No, wait, no.
She said she was just playing. She knows that 5 and 5x are both 5s doesn't mean anything. Alright, so there are no like terms in each pan that I can combine. I want to put the x's on one side and the constants on another. When I move it, it's going to become the opposite. So let me first get rid of the 29. So how am I going to get rid of it? Minus 29. What I do to one side, I have to do to the other side.
You don't know what you're multiplying. Are you subtracting 5 and minus 29 or 5 minus 29?
You got 5x, and over here you're going to combine what is 5 minus 29. Negative 24. Thanks, Hayden. What? Alright. This 5x is out of place. It's on the wrong side. So I need to get rid of it.
But wouldn't we have subtract 3 from 5? Or
Subtract
5
it.
from 3?
You're going to subtract the 5.
Oh, okay.
5x. Because if you take the 3 off of the left-hand side, there's nothing left over here, right? It'll be like Autumn's head sideways. So I got to fix it back. Right, it'll be nothing left over here if you get rid of the 3x. So bring the 5x.
She did hit me on this side, it's not going to be down. But if she hits me on this side too, then it's going to be down.
Alright, here's what I have left. I'm going to finish the problem. Don't look up unless you want to check your work. Yay! Are there questions on number 4 at this point?
The answer still the same if I would have cross canceled negative 24 and negative 24.
So it's negative 24, and then we put the minus 8.
What do you mean, cross cancel?
You know, if you did 8 divided by 8, what if you did 24?
You can't because you're not dividing the 24s up. You're dividing the 24 among these 8 boxes over here to find out how much each box is worth. Don't subtract that. Do not subtract negative 24 and 8. That's division. Alright, here we go. Last one, number 5. Yes. That answer was x equals 3, by the way. I'll write number 5 here.
Oh, I was trying to subtract it.
What's wrong with number 5 that you don't think it's going to be easy?
It's got a big number.
It has a big number and it has a fraction, but fractions are our friends.
Fractions are my friends.
Y'all are too loud.
Fractions don't like me.
Alright, Atif, take a look on the left-hand side. I need to clean up some stuff. Alright, simplify. Combine like terms. He said negative 5 plus 171. Put them together. When we put it together, what do we get? Negative or positive? Huh? Positive 166 equals x, and I need to bring down my third of x. So a third of x plus 166 is x. That's interesting. So look, there are my 2 beans, my 2 pans, Bryce. What do you suggest we do next? Bryce. What'd you say? What did you say? Yeah, what do you think we should do next? You want to pass? Very good. Subtract. Get rid of the 166. Give him a hand, y'all. We're going to get rid of the 166. And if you get rid of it from the left, you got to get rid of it from the right.
How?
Well, you're just going to take off negative 160. You're going to take off 166. So
From x.
a third of x, this is gone, equals x minus 166.
Oh.
Let's take this. We need to move this x because it should be over with the other x, right? So we're going to pick it up and get rid of it. If we take it away from the left, we need to take it away from the right. That's 1/3 x minus, what kind of x is this? What do I put instead of 1x? 3/3. 3 over 3 is 1. Alright, finish the problem. Don't look up. Oh, we have to divide by a fraction again. Remember, to divide by a fraction, you multiply by its reciprocal. Multiply by 3 over 2. Negative 3 over 2. Put this over 1. Okay, look. I'm going to do this little magic trick that my 6th grade teacher taught me. 1, 8, 3. Cross cancel. Now, 83 times 3 positive 249.
249 over 1. Oh my gosh, so X is 249.
Alright, last few minutes of class. Here's what I want you to do. I want you to take out a sheet of paper, put your name at the top. Now, on that sheet of paper, I want you to put your name, and I want you to write this problem. X plus 3 plus X minus 8 plus X equals 55. I want you to try to solve that problem. When you have finished attempting to solve that problem, I want you to rate yourself. Give yourself a smiley face if you totally understand and you're happy with what you have. Give yourself a side face if, I kind of get it, but I'm not totally sure. And a sad face if I know I need some more work on this. When you finish, I want you to put it over on the kidney table and pack up.